Okay, so here we are at the desk of the equipment. So we have here our Pasco interface that we've used before. We have this field sensor that we used for last week's lab. Now here on the side with the print, remember we said this thing measures the field in 2 dimensions. So it has an axial field, which would be, in this case, if you look at the print, it's pointing to the, inside the probe. This is the probe, so inside. So it says axial with the arrow pointing this way, and then it has a perpendicular one, which we're calling radial in our case, which is pointing out of this side. So this means that so this thing is like an axis, and so what it does is when the axial field is pointing into the face of the probe, it reads it as positive, and when the radial field is pointing outside the face of the with the print on it, it reads that as positive. So this thing is just saying that positive this way is positive, and this way is positive, and then the field is a vector which has components, which is why we have these 2 components over here, right? So axial and radial, or perpendicular in this case, right? And then here we have this rotary motion sensor, which actually needs to be, let's see how we want to have this guy pull up like so. So we want it to go like this. Pull up, yes. All right, and so remember last week we said, so this guy keeps track of the strength of the field, the B field, and this guy keeps track of the turns, right? So they both work in tandem. One keeps track of the strength of the field, the other keeps track of the angle that you current. You need them both to get a nice looking graph. Okay, so now we'll go to the folder, physics lab experiments. We want, what do we want? 10 field current coil. Boot this guy up. Turn on our Pasco interface. We need this guy. All right. And then now what we want to do is run current through our solenoid, which again is this guy. So this guy is a solenoid. In here, I mean, it's wrapped in some yellow tape, but in here there's a bunch of coils in it, 600 coils. Right. And then this thing is wired such that if we connect these 2 points, if we apply voltage difference across these 2 points, we'll run a current through this guy. Only thing is we don't know which direction the current is going. So we said, remember, in principle, it could be going counterclockwise, right, or clockwise, which we don't know off the bat. Okay, but what we're going to do is use this guy and the properties of the field that we know, right-hand rule and everything, and this guy's convention. And then from looking at this guy and using our tools over there, we could kind of deduce which direction the current has to be going inside the coil. Right? Okay, so we have software is booted up. We'll go to procedure here. Oh, and then we need to, let's make sure, first of all, that we have our current. So what we want to do is have something like this guy like so. Trying to get it as flat as possible to reduce the error that we'll have in U base. And so make sure this can be set up. And so we want to keep track of the distance using this guy. So if we're pulling up, no, it's turning the other way. So we want to pull it up from this other side. Like so. Okay, so that's good. And then we want this here. So the setup gets kind of tricky. Oh boy. Okay. Right. And so now we need to apply a voltage difference across the solenoid, so we need just a couple of example lines. Grab them from here, and then we'll jump from source here. So this guy, and then we'll go from here. Here. Okay, and then now we need to apply voltage difference, so we need some C cables. Alright, so we need this guy, and then, actually not this guy, what am I? Two cables. Alright, so now we need to jump from our passcode box, which is our source. So try to see positive and negative. And so I want one to go one end of the phone, and then the other one down. More or less. Right. And so now what we could do is test to see whether the connection's good by just trying to acquire a sample of some data. So if you come here, you see the record button is on. Well, it's highlighted, or you can highlight it. And so if you click this, we'll see that now we're pushing this much current, which is what you expect to see, about what you expect to see if the thing is running like it should. So now we know we have current running through the solenoid, which means we have a field. And so now we need to take some measurements of this guy. All right, okay, so I'll stop this guy. Now we know that it's working. Delete last run. Okay, and so now in the procedure, in the data, we have to get okay, so here in the table, we have 4 rows you have to populate. Center, east, west, and east reversed. Now these refer to the center of the solenoid, the east side wall of the solenoid, the west of the solenoid, and then east reverse is just east, doing east again, but before that you reverse the current, which is akin to just switching these two leads. Right, so if we switch these two, that means we switch direction that the current is going, right? And so center, east, west, and then east reverse. Okay, and so we'll do center first. And so what we have to do now is come here, what center is, and then just like last time from last week, what you want to do is make sure this handle, the handle of the probe, stays at the same orientation for all your runs. So you can't do the first run with the handle like this, and then the next one with the handle, you know, like turned or some other thing. So it has to be either like this, or you know, the other one like this. But you know, this works best for me right now, so I'm just gonna keep it like this, right? And so for the center run, we'll what we want to do is pull this guy from the bottom, and the whole while we want to try to keep the probe at the center of the solenoid the best we can. Obviously, you're doing this by hand, so you know there's going to be some error there, but that's basically the idea. So the center run is pulling this guy up, keeping track of the rotation, field strength, as we're pulling the guy up through the center. When we do the east, again, so remember, north is straight ahead where the board is, so east would be that way. And so for the east run, we'll same procedure, but now when we pull the handle up, when we pull the probe up, we want to make sure that we're pulling it grazing the east side of the wall the entire time, right? So center is in the middle best we can. East, we'll bring it up, grazing the east wall the whole way, and then pull it all the way out. West, you know, not other things, so we're going to graze the west wall as we're pulling all the way up. And then east reverse is just east again with the leads or current reverse, right? And so that's basically the idea. And so what you see here, we actually have data generated for you guys, so you can look at the file. But I can do a quick demo so you can see what it looks like. I mean, the data is going to be bad, but you have better data in your files. And so if I click here, record, and then now I'll pull this guy. I'll try to do the center line. And you can see that. And then now I'll click stop. Right. Okay. And so this is what data looks like, or this is bad data. You have better data in your data files that are going to be sent to you. But so this is what it looks like. So this is actually, if we come here to the axial tab, and we look at the thing we just graphed. Oops. Yeah, actually, yeah, no, scale to fit. There you go. So this is data we have. So this is actually the axial field. You can see it has just one peak, one hump, right? We'll explain what that is. You'll notice that it's positive, right? So this is, 0, positive. So that tells you something about which direction the field was going based on the convention of the sensor like we talked about. And then if we come here to the radial field tab and look at our data, you get something like this. I don't know if you noticed, but let's go back here. Take a look at the amplitude. You'll notice that this is in millitesla, so this is about, I don't know, what is that? Maybe almost 20. It's almost 20. So almost 20 millitesla. That's the field strength of the axial field in the middle. If you look at the radial field, you'll see that it's super tiny. So this is many, many times less than the axial field. And there's a reason for this. We'll talk about it. We'll talk about what this is in a minute. But this is basically a procedure. So this is a center run. You have each of the runs you're going to do is going to give you two graphs. So an axial graph, this guy, radial graph, this guy, and then you just do an analysis based on the data that you get, right? All right. So I guess the other thing we need to talk about, even though you don't need this for the data, so you see how this thing isn't, for those of you that have your manual, this guy isn't, the peak isn't centered on 0. This just has to do with the fact that I didn't calibrate it. There's a procedure here for calibrating that they did when they did the procedure for the actual data you're going to use, and the graph should be better. But this thing's supposed to be centered at 0 thereabout, plus or minus 3 centimeters or something. It's supposed to be a bunch of runs over until you get something that's within that threshold. But it's whatever. This is just for just a demo. So all right, so that's basically the procedure. That's how you get the data. That's what data looks like. Now let's go and talk about how to interpret the data.